This diagram describes the database management system architecture. So this includes the overall architecture. So this includes various types of users. This includes like null users. This type of user can use the certain application interface in order to interact with the database system. They can't able to create any program by their own. That's why they here it is written as use. Naive user in the sense they can use the databases only they can use. The same way the application programmers in the sense they can write their own program with the help of some application programs and then compile and then use the same. So this is the second type of user like application programmers can write their own programs. Third type is sophisticated programmers. They can use some quality tools in order to interact with the database system, but they can no need to create the programs for the same. So that's why these developers use the system, use the tools in order to access the database system. Finally, the database administrator. They can use some administration tool in order to access the database data with the help of some database queries. So these naive users, application programmers, sophisticated users, database administrator. So these are all the different type of users going to interact with the database system available in the database. So in the next level, application interface. So this interface is used to help the naive user in order to access the database. An application programmer in the sense, here the user name is application programmer, so they can write their own application programs and that is represented here. So they can be combined and used to access the database system. Then some query tools. So this tools represents there are a number of numerous tools are possible in order to access the data from the database. So sophisticated user can use those tools based on their requirement in order to access the database. So that is represented for any tool they used in the sense that is represented here. Then administrator in order to handle the database system in the repository or the database in order to handle the same like authorization process and all they will use. For that purpose they can use this administration tool. So the second level. Next one is application programming code. So this code is passed to the query evaluation engine in order to extract the data from the database. So this application programming object code is going to pass the data to the query evaluation. Then next level user like compiler and linker. So whatever the programmer you written the program that must be compiled and linked with the help of this application object code, then passed to the evaluation query. The same way this next user like query tools. So while using the query tools, those users data are extracted and passed to the DML queries. So that query is passed to the DML compiler and organizer. So this organizer going to pass to the in order to evaluate the code those queries. It is passing to the again query evaluation engine. The same way the administrator tool details. So whatever he try to access the same, that is interpreted through this DDL. Like the database design is checked by the integrity constraints and all checked by this DDL interpreter. So this administration tool details are linked with this DML queries. So while accessing the data from the database, through this query evaluation engine only all the data are evaluated and then passed to the next level like from the naive users, then application programmers they are passing through the application programs to the query evaluation engine. The same way query tools which are extracted from this sophisticated user that also come to the query evaluation engine. And finally administrative tools, those tools details also passed through the DML queries. Then it is compiled with this DML compiler. Then after compilation this comes to the query evaluation engine. So So all the user, whatever the user uses the database, in the sense all are passed through this query evaluation engine. This going to encode the query, whatever the users, any users request, so it will evaluate and then pass to the next level. For example, first one is just connect to the buffer manager. Buffer manager, in the sense, it is responsible for fetching the data into the main memory. So whatever the data available over the repository or disk, it's going to fed into the main memory. That is the purpose of this buffer manager. Then file manager. So this is going to allocate the space for the data. So this file manager manage all the spaces for the data available in the database. That is the purpose of this. Then authorization and integrity manager. So this will provide the permission to the user to use the database system. Authorization and integrity manager. Whatever the user requests, so based on the request, this authorization will check the authentication and provide the permission for the same. Next, transaction manager. So this is very important thing. So while doing the particular process over the database, it will be responsible for whether the data, the whole process is completed or not. If in case of any failure occur, in the sense, it must follow the transaction process conditions, like if the transaction is successful, it must update the same in the database. Otherwise, it will retain the same. It will remain the same, like roll back the whole process. Then only the database will be valid. So that is the process of a transaction manager. So all these are known as the storage manager. So the storage manager will manage transaction manager, authentication and integrity manager, file manager and buffer manager. So this will handle all these functionalities. So all these things are connected with its physical system. Physical system, in the sense, here data block. This is connected with buffer manager as well as file manager. So this stores the actual data of the database. And then indices in the sense, like fast access to the database. And so for frequent access of the database, it will create the indices, like indexed available in the particular book. So for quick access, it will possible to create the indexes over the database. Then data dictionary. So this dictionary is created and it stores the data about this data, like metadata. So the metadata details about the database is stored in this data dictionary. Whenever the authentication authorization process it requires, in the sense, they can verify the same. So while creating each and every database, the corresponding data is metadata is stored in this data dictionary for future or further references. So that is the purpose of this data dictionary. So these are all the different stages of architecture. So usually any user can request their willingness to throw this any of the interface, and it passed to this compiler or linker. Then it is evaluated by the query evaluation, and with the help of the storage manager, it has managed those requests, and from the data available over the database repository, it is extracted, and the same way it is reversely sent to the users, whoever they request or whoever they created the same. So like this, the database access process is routinely doing the same. So here we have two major parts, like query processor and storage manager. Like mostly disk storage. Disk storage in the sense, like database, it includes data, indices and dictionary. These three are occupy the physical space over the database system. So here these two terms are described. These three are described here, like query processor, storage manager and disk storage. So first we will see what a storage manager include the following factors, like authorization and integrity manager. So as already said, this describes the same, like authorization. Whoever the user requests, it is responsible to provide the permission for the same. There's a transaction manager. So it It is responsible for the database validity. So even though failure occurs, it should follow the validity of the database by remain consistency. So it should follow the in case of failure, it should roll back the whole process in order to follow the same. Then file manager going to allocate the space for each and every database file. Then buffer manager, this is an important role here because sometimes space of the memory size of the buffer manager may be larger than the main memory. So in that case, it should manage while feeding the data from buffer manager to main memory. So it's playing major role in the database system. So these are all the terms comes under the storage manager. So while using this, it's going to follow the following data structures like data files, which holds the data available in the database. Data dictionary holds each database designs metadata for further uses or process. Indexes will hold the indexes, fast accessing database over the available repository. So these are all the various data structure available over the physical system in the database system. Finally, query processor. So this processor includes DDL interpreter. This is going to analyze the design of the database, whether it includes the primary key or binding constraints. So all are checked by this interpreter, DDL, data definition language interpreter. Then DML compiler in the sense, whatever the query data manipulation language receives, it's going to compile and going to process and pass it to the next level. So it's going to compile, it's going to verify whether the correct database names are given or correct attributes or columns are given. So those are checked by this compiler. And query evaluation engine, this is playing a major role in this database system. So this is going to evaluate the row interpretation work as well as DBMS compiler process. So after evaluation, only this passed to the next level in order to store, in order to extract the data from the database. So based on this evaluation only, it's the database system going to extract the data from the database. So that is the purpose of this query evaluation engine. So this three major points describes the database system architecture.